Okay.
Okay, hello everyone. Welcome to the second episode of Let's Discuss the Paper right after reading it in 2023. So in this kind of session, we choose a paper and then read it within 2 hours and a half. And then we come back to discuss it. So let's start with some self-introduction first.
Hi, I'm Yota Koshima. I'm a research assistant in Japan.
My name is Qian Chen, and I am a PhD student at the CTL Lab in Monash University, Australia. So today we are going to discuss a paper by Waitman and colleagues, Nature Communication paper published last year, titled Local Features Drive Identity Responses in Macaque Anterior Face Patches. So I'll give a brief summary and then we'll open the ground floor for discussion. Okay, so in terms of face processing, it's almost like common knowledge that humans and other primates are very adept at recognizing and differentiating different faces and even interpreting the emotions. And they also have like dedicated face regions in the brain for doing all these complex processing compared to other objects. And it has been a very popular research question in terms of how do these brain regions process facial information for such an adept facial recognition. In past studies on facial recognition, people tend to find a lot of evidence on the combination of facial features which drives the facial recognition compared to just recognizing individual facial features. For example, if you randomize the organization of a face rather than putting them in the place that they should be, then it will severely disrupt people's ability to recognize the identity of that face. While these kind of findings are pretty consistent in humans, in primates, however, there are mixed findings about the contribution of these individual features and the global organizations. So in macaque monkeys, they call like these face regions face patches, and they basically found that in the face processing goes from early where they process individual features to middle region where they start to involve a little bit of holistic processing to look at the interaction between features to like higher regions such as the anterior, medial, and anterior fundus regions, which heavily emphasize on the overall configuration of these individual features rather than the individual ones. But it is yet unclear in these higher regions specifically, what are the relative contribution of individual features versus holistic processing. Especially, they are interested in this paper, they're interested in this highest or higher region, which is the anterior regions. Do they have, are they still tuned to some degree to local features, individual features of the face? So the goal of their study is to examine the encoding and processing of individual face features such as nose, the eyes. Oh, there's no nose, just the eyes and mouths, or like the inner face, outer face, and their combination within the entire face, with the head, with the body, or even with the natural scene background in the anterior regions of macaque monkeys. And to achieve this goal, first of all, they develop a set of pretty unique stimuli. So these stimuli are created by first they took some original monkey images, and then from each image they extract various image components, including something like the background or like the body of the monkey, the head, inner face, outer face, eyes, mouths. And using these components, they create some novel monkey images by erasing certain parts from the original monkey and then replace them with the combination of the same parts from other monkeys. There are 4 different recombination and replacement categories, including replacing the original monkey's eyes and mouth, like different pairs of like eyes and mouths, and combination of inner face, outer face, different combinations of head and body, and different combination of the entire monkey with the background. And then they have some macaque monkeys to passively view these novel images while their activity in the brain in the anterior regions are recorded by single cell recordings. So in their analysis, they are particularly interested in whether single face or body parts are more likely to drive, diversive neural responses in the anterior region, or the combination of these features are more likely to have like selective responses. And at this point, from like previous findings, you might expect like, of course, it's the combination of features because anterior regions are traditionally considered to emphasize on holistic processing. However, surprisingly, they found that neurons in the region of interest are specifically tuned to single facial features rather than a combination of them. For example, you can have a neuron that are tuned specifically to the eye of a specific monkey, but not the mouth of another one or the eye of another one. And among all these different facial features of like different level, from the eyes, mouth to like the face, body, neurons are most strongly tuned to the eyes and mouths compared to the outer face, head, and body. And most importantly, the neural response to these individual local face components predicts responses to the entire image. So as long as you show the same pair of eyes, it doesn't really matter whether you replace the head or like the background or like the body. You're just gonna get very similar neural responses. So in summary, quite different from our common expectation about face processing in the brain. For macaque monkeys, at least, responses in anterior region, which is very high level in the network, can be strongly tuned to individual face features rather than the configuration or interaction between them. Yes, that's it. And any questions?
No, thank you for your great summary. It's really, concise, easy to understand, and capture all the, important key point of this paper. So no question.
Thank you. Any things like for discussion you want to bring up?
Yeah, I have one thing. So it's more like how does the brain encode the information, external world informations. So this paper kind of suggests maybe we can't find like a single neuron that encode the specific identity, face identity. Of course, in the discussion, they mentioned other possibility that, in the more anterior part, some, I forgot where it was, but the perirhinal.
Perirhinal, yeah.
Perirhinal cortex might have that kind of, neuron that, encode a single face identity. But at the same time, the authors mention other possibility, meaning that, we don't have such kind of neuron. Instead, some kind of computation, for example, synchronization of neurons and encode the face identity.
Yeah.
And
so sorry. Please go on.
Yeah. So my question is, do we have that? We know that some, very famous finding like Jennifer Aniston neurons or Clinton neuron, these kind of suggest, okay, in the end we find single neurons that encode a single identity, but I'm not sure whether that's applicable to all identity, because if that's the case, then we should have the same number of neurons as the number of, identity.
Increase, yeah.
Yeah.
Well, that's true. I actually have a very similar point to you.
Okay.
They also, for this particular point, right? The authors also bring up a very interesting point where the face structure or like the overall configuration, which denotes identity, it could be processed by middle regions, which is, according to their introduction, is lower level in the network.
Yeah.
And yeah, that's surprising because you would normally expect the hierarchy as it goes up, it becomes more holistic over local features or like individual features. And yeah, and if that's true, why do the anterior region goes back to individual features when the lower region has already processed the holistic structure?
Yeah. So yeah, it's this finding is really interesting, but it's really difficult to get some implication from this paper. And so if the brain works in a population called manner instead of single cell coding manner, then but still I feel like we need some readout component for that, because yeah, sure, the population neuron some encode something, but in order to use that information, we have some component to read that information, and in the end, by recording that readout component, neurons or something, we should be able to predict the single person identity, or
From synchrony.
yeah, or yeah, exactly. So in that case, that readout component corresponds to single neuron, or single corresponds to single person or face identity.
Can
But
you actually do that?
I don't know. But
Because what I would think of is you have, let's say you show people four different person, like four different concepts, and then you find that their synchrony pattern are different in four conditions, but I'm not sure if you can find the specific synchronization pattern of that particular concept, like whether that requires too high of resolution in terms of capturing neural activity.
Yeah. But my point is that in the end, the brain needs to use the information if it's encoded by the population of neurons.
So how does the brain use that?
Yeah, or maybe the brain doesn't need that kind of readout component, maybe. So the reason why I'm talking this is yesterday I talked with Mao about quantum cognition idea, and I heard you're working on similar project.
No, he found hope in my initial data is what is going on. Yeah, anyways.
Yeah, so yeah, anyway, so in Mao's explanation, it may not be relevant to quantum cognition in the end, but he basically talking about this kind of computation, the single neurons encode the single some, cognitive states or values, or the brain has the state represents some, distribution, probabilistic distributions. And then that distribution fluctuate, and that's something, I guess, to do with, quantum probability theory.
Oh,
I
wait.
don't know. I'm not, expert of this quantum mechanics, so I don't even know the basic of the quantum mechanics. But
Yeah, so when he says the probability distribution, this is a very basic question, but I'm gonna ask it anyways. Like, how do they get the distribution? Do they get it by recording neural activity over time to get this probability distribution, or this probability distribution comes from like when you measure them, you have some chance of measuring it incorrectly, hence the probability distribution.
so my understanding is that it's not, I don't know whether it's a correct way to say it, but instead of thinking, or start thinking about probability distribution itself, I guess you can, you'll agree that the brain will have some competition between different populations.
Mm.
And one population, for example, encode one, features, and the others encode similar features.
Mm-hmm.
And then that competition is going on, and then if one beat the other, then that will be the one maybe you will perceive, or that will be used for it in other, cognitive, processing, decision making or something. And that kind of competition, the strengths can be considered as a probability or something like that.
Mm.
So this one is more likely than the others, and this kind of dynamics can be captured or expressed by the probability distribution dynamics of it.
I see.
So I don't know how the brain correct the or calculate the probability. It's just how the brain behave.
I see.
Mm.
Could their findings be instances of this, as because their findings are very different from previous studies where anterior regions are all for holistic processing.
Mm.
Could it be an instance of something like this?
Yeah.
But coming back to the Jennifer Aniston, the classic study,
Mm.
I remember those neurons are from different regions,
Mm.
like medial cortex or something. It seems to be, I don't remember correctly, but I think it also has to do with memory or something. So it could just be different regions are doing different things. But yeah, I need to look this up. I'm literally looking at now slides.
I am now, checking the Wikipedia, and then of monkey. Yeah, maybe you're correct. Hippocampus, maybe.
Ah,
Yeah, if that information is important, then the neurons in hippocampus encode, a single neuron encode that specific identity. But otherwise, no, this brain will not store that information in hippocampus.
yeah, maybe that's why. It's just random normal monkeys does not reach that level.
Yeah. So in that case, so basically we don't need or single neuron that encode the identity
Mm.
to perceive that person or face.
Mm. Oh, it's possible. Or it's possible that they're somewhere else.
Yeah. Um, mm, yeah, okay.
Well, that's what they say in the discussion.
Yeah. Yeah.
Always possible that it's somewhere else.
Mm, mm. It's, it's difficult. Mm. Yeah, but it seems like, the population coding is in the end important
Mm.
for identity instead of, single neuron.
Mm. Can we
Mm.
actually say there's no hierarchy then if it's not about, one level to another level, like one region transmit to another region, but it's more just about whether you're looking at single neuron or like neural population within the same region.
I guess, still we have some kind of, hierarchy, at least in visual areas.
Mm.
You know,
True.
yeah, edge detection or some
Mm.
kind of, lower level processing happening in the higher area. But that's too, because, here they said local feature or something, facial local feature. But, that when they say that, they mean the eye or mouth.
Mm. Mm.
But that can be, decomposed into a combination
Edge.
of lines of edge. Yeah, exactly.
Mm.
So
True.
yeah, we need some hierarchy to get that point. But after that, we don't need the hierarchy, I guess. And then
Mm.
population coding do all the stuff. But I don't know. I just don't know. Maybe, another person find a, neuron in other area again that
Mm.
represent this identities, face identity. Mm,
Yeah, I
yeah.
guess with this kind of surprising finding, it opens the door for like many, many follow-up studies.
Mm, 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 yeah. Mm, interesting and unexpected. They
Yes.
explicitly says, the result was unexpected.
Mm.
Mm, yeah. It's so clear that, that neurons in the area encode the eyes, mouth, instead of the
Combination.
configuration of these.
Yeah, like the figure basically shows the interaction are, the responses to interactions are basically flat.
Mm, mm,
Yeah, and that's pretty surprising.
mm. It's surprising.
And do you have anything else?
No, I don't have anything. Yeah.
Also not for me. So yeah, I guess with that we can conclude today's let's discuss a paper right after reading it session.
Yeah.
See you next time. Bye
Thank
bye.
you.